There are 3 symmetry tests that you need to be aware of. The first one is the x-axis symmetry test. And how do I know if something has x-axis symmetry? So let me show you what x-axis symmetry, first of all, would look like. So here's a picture of a graph that would have x-axis symmetry. Notice what's happening. It is touching the x-axis. If you fold it over, imagine just folding this picture over this x-axis right here. Does this half look like that half? Does each point look like it would land on each point? If you remember from like kindergarten, I don't know if you remember this, like I do remember my teacher, she would draw like put paint on one side and then you'd fold the paper and you'd be like, oh, look at that. That line was the symmetry line, okay? And that's the same thing here. Let's talk about the numbers wise. If this was the point, I don't know, 2, 1, what would its mirror point down here be? 2, -1, right? So what just changed signs? The y. Okay, so here's the algebraic way of doing it. If you have x-axis symmetry, you are going to replace every y with a negative y and produce an equivalent equation. If you don't understand what that means right now, don't worry. We're going to do examples in a minute. I just want you to write this down. So that's x-axis symmetry. Now let's do y-axis symmetry. So y-axis symmetry you would be flipping over the y. So let's just take, for example, this guy here. Okay, good old absolute value guy. So if I flip over the y, that would be this vertical line right here. This is the y-axis, right? If I pick this point right here, let's say this is the point, I don't know, 1, 2. What's this point right here? What's its mirror image over on that side? -1, 2. Oh, what changed signs now? Oh, so when you flip over the y, the x changes sign. So you are going to replace every x with a -x and produce equivalent equations. Okay, so x-axis symmetry, y-axis symmetry. Then there's one more. It's called origin symmetry. And let me explain origin symmetry. So your most common origin picture, let's see, would be this one. Okay. And here's how you test for origin. You put your pen at the origin and you flip it upside down 180 degrees. Does that look exactly the same as that? Yes. So you need to flip it upside down. Because you can do this on your calculator. You would just look at the picture and then go like this. Whenever I do the next quiz, I see a lot of people going like this. And it kind of makes me happy. But that's all you have to do. If it looks exactly the same, like there's been no shift, then it has origin symmetry. Okay? Mathematically, what's happening is this point right here, let's say this is the point 1, 1. This point down here, its mirror from the origin would be, guess what? Oh, so what happens there? You replace every x with a -x and every y with a -y. So that would be your algebraic way of doing it. Replace every x, y with a -x, -y, and produce axis or origin symmetry for each one of these equations. And I'm going to, hopefully, you'll find yourself a little trick. It'll make sense in a minute. So we're going to start with this one. And sometimes when I do this, I always give myself a little clue. Like if it's x-axis symmetry, what am I plugging in again? What am I plugging in for y though? No, but don't get confused. I know we're going to do. What am I, to find x-axis symmetry, read what's above it. What do I have to plug in? A negative y everywhere I see a y. Okay, it's weird, I know, but you're going to plug in a negative y. If I have y-axis symmetry, I'm going to replace every x with a negative x. If I have origin symmetry, I'm going to replace every x and y with a negative x, negative y. Okay, this, I know it can get confusing. We just did zeros, Mrs. Seta, I know, but welcome to PreCalc. We do a lot of different stuff. All right, so I'm going to take the y, I'm going to put a negative y there. So x minus negative y squared equals 1. What happens when you square a negative? Doesn't it become positive? So wouldn't I just be able to rewrite this equation as x minus y squared equals 1? Isn't that the same thing? So guess what kind of symmetry this has? This has x-axis symmetry. Check. Negative x minus y squared equals 1. Is there anything I can do to manipulate this equation to look like this? Anything? No, because wouldn't the negative x always be negative x? I can't get it to be positive x. I can't get this to be positive and this to be negative and this to be positive. I cannot do it. So this does not have y-axis symmetry. What about both? Let's try it. Let's put a negative x in for x. Let's put a negative y in for y. Whoops, I'm running out of room there. What would happen to this guy? Wouldn't he become back to being positive? Y squared equals 1 minus, but what about that negative x?
It's still going to be negative.
It's still going to be negative. It's not going to do anything, so no. So this equation right here, the only thing it has is x-axis symmetry. That's all it has. Okay? Let's do another one, because I know this is the first time you're seeing this, and you're like, I don't like this. Too bad. Get over it. You will like it. It's not that hard. Okay? Let's do it again. X-axis symmetry. Plug in a negative y. X times negative y equals 4. Simplify that for me. What do you get out? X times negative y. So what do you get out? Negative xy. Is that the same as this? Okay, let's do y-axis. Let's plug a negative x in times y equals 4. Simplify that. Negative xy. Is that the same as this? No. Well, let's do both, though. Negative x times negative y. Hey, what's a negative times a negative? And what do you get out? Is that the same as that?
Yes.
So I have origin symmetry. All right, try these two right now. A negative y right here, and I square it, what's going to happen to that equation? Isn't it going to go back to its original self? So does this have x-axis symmetry? Check. I'm doing this one, by the way. How about if I plug in a negative x, and then I square it? What's going to happen? Going to come back to itself. Check. What if I do both? Comes back to itself. It has all three of them. Do you know why? Do you know what this picture looks like graphically? You should. It's a circle at the origin. It actually has a radius of 2. And if you look at a circle right now, is that not flipping over the x and looks like the other half? Could it not flip over the y? Could you not turn it upside down and it look exactly the same without shifting? That's why knowing what graphs look like is also helpful. Okay? Let's do this last one here. Can I plug in a negative y and not have to change this equation at all? No, because if I plug a negative y in, it would make it y equals positive 8x, which is, so that doesn't work. Can I plug a negative x in? No, because then that would become positive 8x, which is totally different from this one. Could I do both? I actually could, couldn't I?
Because if you make the y would be a negative. And the x would be a positive.
Right, and then you could manipulate it back. So this works, and here's why it works. If you know, again, what this graph looks like, which you should, this is a line that goes through 0, 0, and you would go down 8 over 1 or up. And look at that. If I flip this upside down, I have the same exact picture. I have origin symmetry. Now, if you didn't like that, sorry, because you're about to do a whole work. Again, hopefully you noticed that something. If it has an even power for that, whatever that X or Y is, it's going to work out, right? Okay. So for this one, for X-axis symmetry, I have to plug in a negative Y. Wouldn't that work?
Yeah.
So check. Would it work for the plugging in a negative X? No. Would it work for both? No. So it only has X-axis. Number 5, can I plug in a negative Y? No. Can I plug in a negative X?
Yes.
Sure can. Can I do both? No. So this has Y-axis. How about an absolute value? Can I plug in a negative Y? No. Can I plug in a negative X though?
Yes.
I can, and take the absolute value and become the same. So that has Y-axis symmetry. Can I do both? No. Okay, moving over here. So this might be tricky for you. Where do you plug a negative Y in? It doesn't have a Y, right? Well, think of this visually. Do you know what the X equals negative 4 line looks like? You should. It's a vertical line at negative 4, correct? So can I, well, let's see. Is it flipping over the X-axis? Sure is. Is it flipping over the Y? No, there's nothing over the Y. Does it have origin symmetry? Well, watch. Right now it's on the left of my screen, and I flip it upside down. Now it's on the right. No, it doesn't have origin. So the only thing it has is X-axis symmetry. This one, didn't I just do one like it? This is a what? Circle. So what's going to happen to it? It has all of them. What about this one? So if I plug in a negative X or negative Y, wouldn't that become positive 3Y? So it's not working. If I plug in a negative X, that would change this whole entire equation. It wouldn't stay the same. What if I did both? It still doesn't work. Sorry. Because a negative X equals 5 minus 3 times negative Y. That would be negative X equals 5 plus 3Y. Even if I tried to make this positive, I'd have to change this to negative and this to negative, and that's not the same. So this has none of them.
So the 5 is the reason then?
Yeah.
Okay, that's why.
Yeah. Yeah, and the other one it worked out. Y-axis symmetry. Why did they name it then that? I don't know. I'm not the one who named it, okay? Here's how my teacher reminded me and remembered I do what she had done, and I thought this works out. See the V in even? Make it go like this. Even has Y-axis symmetry. Mathematically, the way we write that is, again, that we can plug in a negative X and we get out the original function. So it's a function with Y-axis symmetry. An odd function is a function with origin symmetry. How do I remember that? Odd origin. These are amazing. Which means I could plug in a negative X and get out a negative Y. That's the functional notation for it. So you will be asked the following 3 questions. Is it even? Is it odd? Or is it neither? And we're going to write down these last 4 examples, and then we're going to do... All right, so there's a trick to this. Very cool trick. It's really easy, and it makes actual sense mathematically. Whereas I feel like the X-axis symmetry plug in a negative Y doesn't make sense unless I visualize it, but this makes sense, okay? If you are an even function, all your exponents are even. What? If you are an odd function, hold the phone. All of your exponents are, guess what? Odd. Amazing. What happens then if you're neither? Even and odd, right? It would mix. Okay, so that makes sense. And by the way, when I say exponents, I mean the exponents of the x's of the variables. So let's just take a look at this one, shall we? We have a 3. What's the power of x when it's by itself? Both of those numbers are, this has origin symmetry. Boom. Didn't even have to graph it on my calculator. I already know it. Boom. This one has a 4. Oh, this one doesn't have an x. Well, yes, it actually does. It is x to the 0 power. When you don't have an x, you actually do. You have an x to a 0 power, because anything to the 0 power is 1. 1 times 2 is still 2. 4 is even. Do you know what 0 is? It is also even. It is 2 away from 2. Every 2 numbers is an even number. 2, 4, 6. So you're 2 away. So this is even. This is even. Guess what this is, kids? This is flipping over the y-axis. All right, here's a 3. Here's a 2. I should just stop right there because I have an odd. I have an even. This one is. And then there's this one. When your variables go to the denominator, you need to be careful. You actually have to, you can't just say, oh, it's going to be even. You need to check it in your calculator, right? Because you don't know the tricks for the variables being in denominators. So just anytime you're unsure, just go to your calculator, type this in. By the way, when you type it in, well, hold on, 2 divided by x squared, zoom 6. Let's just see. Okay, so it looks like a volcano, right? Is it odd? Can I flip it upside down and it looks exactly the same? No, now it's going down, whereas here it's looking like a volcano, right? Is it flipping over this y-axis right here? Does this side flip over to there? So this is even. It did happen to be even. But that's how you know. If you're unsure, put in your calculator. You'll see. All right, so like, look, the first one right here, I see a squared. And what does that 16 have? X to what power?
0.
And 0 and 2 are both done. That's all you have to do. That's how fast you should go through this sheet.
What number 3?
That's 3 and 0.
3 and 0. 1 is even, 1 is odd. So this is, there we go. Numbers. It's okay. Okay, y equals 0. This, for those of you who don't realize this one, this is the y equals 0 line looks like this. It's a horizontal line along the axis. So let's just talk about this real quick. This is where I was talking to Megan about. If you flip this exactly upside down, wouldn't it look exactly the same? So this has origin symmetry, but isn't it also flipping over that y-axis? So that's why this is a both. This is one that will be both. All right, what about number 9? What'd you get for number 9? Caleb, what'd you get?
I got odd.
Correct. Because it's a 3 and a 1. What about this one? So this one I would have put into my calculator, right? Okay. And you get what looks like, if you did it correctly, you kind of look, it looks parabolic with like a, almost like it looks like it's, yeah, parabola here. So is this flipping over the y?
Yes.
Yeah, so this is even. This is y-axis symmetry. This does not have odd axis symmetry. This one, let me forewarn you, everybody. When you go to do this in your calculator, please make sure you put a parenthesis around the bottom or you will get the wrong picture. If your calculator would divide only the one with the x squared and then it would add 1, which means it would shift. So please be careful to do this. The correct picture for this would look something like this. It kind of looks like a bump there and levels off. So what symmetry is that one? It is even. It's flipping over the y. Okay. This one, they factored out the x. I would actually just factor it back in and go x to the 4th plus 2x squared. 4 and 2 make even. This one, well, again, when you plug this in, make sure you put a parenthesis around the bottom. And then I believe this one looks like a weird bird. It kind of goes like, has a cusp, what's called a cusp. Yeah, because you need to put parentheses around the bottom. That's why. Even or odd, what do you think? See how easy that is? So if you get lost tonight, you put in your calculator if you feel good. So that was 2 things we've learned about x-axis, y-axis.